Welcome back. It's time for video 2 from Unit 7. In this section, where instead of going through the tedious calculations that we saw at the end of our last video, we'll introduce the formula for compound interest. We'll talk about the values that are involved in that formula, and we'll grab a calculator and make some progress. So let's run this PowerPoint, take a look at what we got going on, and move us through the video. All right, so you notice that it's all about you and a calculator. I don't want to do anything with the chart. I don't think it's necessary. I think once upon a time, yeah, maybe it facilitated being able to solve problems where it was hard to raise things to powers. Your calculator is going to do all that for us. Here's our compound interest formula. You'll notice that it's going to involve some exponents up there, some values for us. Take a look at what we've got. A is the future value. How much does it grow into at a certain point in time? All right. P is the starting value. In the past, we've called it principal. How much are you investing right now? What's your value presently? R is the interest rate, again, as a decimal. Be careful with N. It talks about how often in a year we're compounding our money. So if you see phrases like quarterly, that means 4 times a year. On the problem we did a moment ago in video 1, it was once a year. So that was annual and N was 1. And that's the easiest we could have possibly looked at in our tedious example. T is time in years or parts of years. So if it would be 6 months, T would be a half. All right, there's a formula. You are not expected to memorize it. You have access to it. You are, however, intended to be able to use it as we go through. Some phrases for us. If it's compounded annually, N will be 1. Semi-annually, N will be 2. Quarterly, that's 4 shots a year. Monthly at 12. Weekly, 52. Compounded continuously, your book doesn't deal with, but some of you may have done it in a previous class in high school, and you may have met E for compounding with continuous. We're not going to consider it in this course. All right, so what's N? You kind of heard some of these things coming in a moment ago. So as you read the problem, watch out for how often the compounding is going to take place. How many times in a particular year is interest added to your investment? So it's a significant part of what we got going on, and it certainly sets up a value for us relative to N, the number of times that we are receiving interest in any particular calendar year. All right, so here's your first example. Sparky's going to throw $4,000 in at 8%, compounded quarterly. He's going to let that money ride for 10 years. So he won't add anything to it, nor will he take anything away from it. Later on in this course, we'll look at what happens with a staggered series of investments. But for our purposes in Unit 7, it's a one-shot deal. Sparky's throwing in $4,000. Here's your formula. There's the word problem. Let's identify some values. Right, 4,000 is P. That's his principal. It's his starting value. The rate at 8% for 0.08. And how many times a year? You see that word quarterly, 4 times a year. Look at that exponent. It says take N times T. In effect, that figures out how many compounding periods there are in this problem. Again, it was 4 each year for 10 years. So he's going to have 40 compoundings where every time the compounding rate for any particular interval would be 2%. So that's the effect of the 0.08 divided by 4. Yeah, 1 plus 0.02 is not hard to do. It's 1.02. I'm going to make this claim, even though on the screen you're going to see some more numbers. Quite frankly, I'm just as happy as your teacher if you grab your calculator and just start punching buttons right there. A good scientific calculator or a graphing calculator will chain that, and you can go right to one answer. So I don't see the need for you to show me the 2.208 la-di-da-di-da that is the result of 1.02 to the 40th power. All right, I don't think you need to do that. I don't need to see that, but I kind of did it on a step-by-step for you. And at the end of that particular 10-year window, his $4,000 would have grown to $8,832.16. If you needed to know how much interest he earned, it's the difference between those two numbers. So should you want to find the interest earned, you're going to have to do a subtraction. And you found that in this particular context, his initial value was $4,000. It grew to $88,32.16. So he gained the difference So he gained 4,832.16 in interest. Cool. All right, so in this one, we're going to do 2.25, and he's going to compound daily. Oh dear, we don't want to do this the way we did the problem in video one. We're going to run this baby into the formula, attack this thing, okay? And it shouldn't be too bad. We're going to roll it at 20 years. 365. We're going exact on this, although I'm sad I didn't specify that. So we're using 365, the exact interest, if you will. Take a look at what we got. The 10 grand is your principal. That's the initial value of this investment. 0225 is not going to divide prettily by 365 like we saw on the last problem. And we'll have a moment, in a moment, we'll discuss that as it relates to calculator usage. We don't want to round until the end. So you got to keep that full screen calculator going. And your exponent is 365 times 20. I chose to actually multiply the 365 and the 20. That's how that 7240 got there. Again, man, that 0.000, man, that's ugly. If you're a good calculator user, I think you can do it in one shot, and that's how I would advertise. We'll talk about that more in a bit, but I don't think you need to show me these transition steps. In fact, I'm kind of sad I put them in the PowerPoint. All right, at the end of the 20 years, all right, his investment is now worth $15,625.01. Remember, he started with 10 grand, so he earned over $5,000 in interest. And here comes the interest calculation. Again, it's just to subtract, nothing heavy going on here. Here's the calculator discussion. If you're not using TI, I'm sorry, in that what I'm going to show you on the screen works really well for Texas Instruments. But if you've got a different scheme, if you're running Casio or Sharp and you can't discern it, shoot me an email. You and I'll grab a Google Meet together. And we'll figure out the punch sequences for you. That last problem in one fell swoop could be done with the key sequence that you see on this screen. The significant play is the grouping. So we need one set of groups for the entire 1 plus the ugly fraction dude. We also want to group the fraction. So you'll see that we've got nested parentheses going on. We're using a caret to raise to a power, and it's important that you get the 365 times 20 inside a parenthesis set. If you had taken the time to actually multiply those numbers, you could have simply entered that number instead of the parenthesis 365 times 20. You're either going to hit equals or you're going to hit enter at the end of this singing and dancing. And that will find for you the future value of that $10,000 investment. Okay, more words. Calculator does all the work. You don't round until the end. Parentheses are the key. All right, another one for practice if you wish. Sure, why not? 9,000, 6% compounded monthly. So N will be 12. All right, it's going to let it ride for 8 years. Take a look at what you got. 9,000 going in for P, 0.06 for R, 12 because you're compounding 12 times a year. You saw monthly on the compounding. 12 times 8 is 96 compounding periods. A little cleaner divide there. So maybe your calculator could just chill for a bit. You could do some work on your own. And that's what you see on the screen. But now I'd say calculator, just go. 9,000 times 1.005 raised to the 96, hit equals, and you're done. You don't need that line. I kind of am sad I put it in there. So what do you got more? Well, that 9 grand is now worth $14,527.28. So again, if you wanted to know how much of that was interest, well, heck, you started with 9 and you're now over 14. The balance or the difference between those numbers represents the interest earned. So in this case, $5,527.28. So the formula's fun. The formula's nice. Be careful with N. It'll get you in trouble if you're not. Look for how often you're compounding as it relates to the problem, and that identifies the value for N as we proceed. Okay, a bit on bank interest rates and effective interest rates. So some people get confused between the two. It's not really that difficult for us. So I have an example to help us look at it. All right, so there's how you calculate effective rate. your annual percentage yield. You take the interest earned for 1 year and you divide by the principal. And then in effect, what we want to be able to do, if we're investing, we probably want someplace that has the higher APY. All right, so here's your example. 2 banks. Freedom Bank pays an interest rate of 8% compounded quarterly. All right, Best Bank pays that same rate at 8% compounded annually, and they're doing semi-annually, so only twice a year. And you're calculating the APY for each bank. So here we go. Same problem set. Freedom Bank says, let's calculate it, baby. Formula that you and I have used previously in this section. All right, Freedom Bank, if you look up there, they're quarterly. So N for them is 4. Calculator, I didn't go a whole lot heavier. It's you, me, and your calculator. So the $10,000 is now worth $10,824.32. They earned $824.32 over that year. Okay, so that's their interest earned, and there's their APY. It's the interest over the initial principal. All right, so it's 0.0824. So they earned an effective rate of 8.24% at Freedom Bank for that investment opportunity. To compare Best Bank, the only difference is how often they're compounding. They're semi-annually, so N is 2. Again, not a whole lot, straight out calculator run. So your 10,000 became 10,816. Your interest at 816, your APY is interest over initial investment. So your APY at Best Bank is a little less, 8.16%. So over the long haul, basically the idea is that we're earning a bit more interest as time goes by, having had more compoundings per year. All right, so it gives us a method whereby we can compare how one bank compares to another relative to investing money at the 2 opportunities. That, my friends, wraps video 2. I'll be back soon with video 3 from unit number 7. See you then.